Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to combine functions using the four basic operations: addition, subtraction, multiplication, and division. Before we begin, I'm going to assume you're comfortable with function notation and that you can find the domain of a function. All right, so if we're given functions f and g, there are several ways where we can combine them to create new functions. In this video, we're going to examine that with the four basic operations, which mentioned earlier. So suppose I have f and g. I can get a new function. We're going to call that new function f plus g, right? I'm adding the two functions together. And how do we define f plus g at a number x? Like, what's the value of f plus g at x? We can find that value by simply adding the values of f and g. So f plus g of x is just f of x plus g of x. And we do it similarly with all of them. So f minus g of x is f of x minus g of x. Okay. F times g at x is f of x times g of x. And then f divided by g at x is f of x divided by g of x. Now, we do have to make one note when we're talking about the division, which is that we cannot have g of x equal to 0. So g of x cannot be 0 because we can never divide by 0. Now, when we're looking at the domain of these new functions, for the first three, it's all the same. The domain of these new functions will be the largest set of real numbers on which both f and g are defined. Okay, so you can plug in any x into f plus g of x if you can plug in x into f and in g. And then for the last one, it's the same idea, except we also have to exclude any numbers where g of x would be 0. So if x would make g of x equal to 0, we exclude that from the domain. It'll be relatively straightforward to understand this with examples. Example 1. For f of x equals 2x minus 3 and g of x equals 2x squared plus x minus 1, find first f minus g of x and its domain, and then in part b, find the value of the function f times g at 2. So for part A here, we begin. F minus g of x is defined to be f of x minus g of x. And so we simply subtract the two functions. So it's f of x was 2x minus 3, and g of x is 2x squared plus x minus 1. Now, this is f minus g. It's that function, but we should simplify it. So if we do that, we're going to get 2x minus 3. We're going to subtract that whole function g of x. We have to make sure we respect the order of operations. So it'll be minus 2x squared. We don't distribute that negative sign. Minus x, and then minus negative 1, which becomes plus 1. And if we simplify this, we get negative 2x squared. We got to combine like terms. It's the only x squared term. We get 2x minus x is plus x. And then we're going to get negative 3 plus 1 is negative 2. So f minus g of x is negative 2x squared plus x minus 2. Now, its domain, as I mentioned earlier, is the largest set of real numbers on which both f and g are defined. But f and g are defined on the entire real numbers as they are polynomials. Okay, so that means that the domain of f minus g will also be the entire real numbers, or the interval, if you prefer, from negative infinity to infinity. Now for part B, f times g of 2 is just the value of f at 2 times the value of g at 2. Now f of 2 would be 2 times 2 minus 3. The value of g at 2 would be 2 times 2 squared, which is 4, plus 2 minus 1. And if we simplify that, you're going to get 2 times 2 minus 3 becomes 1. And then 2 times 4 plus 2 minus 1 is 9. So the value of f times g at 2 is 9. And that's it. Example 2, for f of x equals 1 divided by x minus 2, and g of x equals the square root of x plus 1, find f plus g of x and its domain, and then f over g evaluated at 3. So for A, so we define a new function f plus g, its value at x is the sum of f of x and g of x. So this just becomes 1 over x minus 2 plus the square root of x plus 1. As far as simplification goes, that's fine. That's as simple as we need it to be. For the domain, now we should look at the domain of each function individually. So the domain of f, x cannot be negative 2, right? If we plugged it, or sorry, positive 2. If we plugged in 2, we'd have 1 over 0. We cannot divide by 0. So we must have x not equal to 2. So basically we could say all x not equal to 2. Now for g of x, right, we cannot have the square root of a negative number. So essentially we have to have x plus 1 has to be at least 0. By subtracting 1 from both sides of the inequality, we see x has to be greater than or equal to negative 1. Okay, so the domain of f plus g is all real numbers that we can plug into both functions, which means the domain should be x has to be larger than negative 1 and then also not equal to 2, right? We have to throw out 2. Since 2 is larger than negative 1, we can't include 2. So if we wanted to write that in interval notation, the domain would be, basically would be from negative 1 until we get to 2, and we do not include 2 in that. So we have an inclusive, the bracket on negative 1 means we include it. And then we take the union from 2 to infinity. And that's how we write all real numbers from negative 1 to infinity, but excluding 2, since we do not include the endpoints when we use the parentheses. So 2 is not included. Now for b, f over g evaluated at 3 is f of 3 divided by g of 3. And we do have to worry, will g of 3 be equal to 0? But we can see if we plug in 3 into g, it won't be 0. So we get 1 over 3 minus 2 divided by the square root of 3 plus 1. So we get 1 divided by 1, which is 1, over the square root of 4, which is 2. So our result here, our value is 1/2. And that's it for this video. Now, combining two functions using the four basic operations, addition, subtraction, multiplication, division, there's a lot of ways that these examples can go. So it's important to practice this so that you can master this material. All right, until next time, have fun.